Hello, this lesson today is going to be about identifying shapes and just naming them properly. We're going to start off with triangles. So there's different ways to name triangles. The first way we're going to look at is by looking at their side lengths, and the second way is going to be by looking at their angles. So if you look at this chart below, all these titles across the top that I'm underlining in blue, those are ways that we would name a triangle based on its sides. So if a triangle is an equilateral, that means all sides are the same. That means they're all the same length. If something's isosceles, that's this middle word, underlined in red, that means that two sides are the same, but the third side's different. Again, same meaning, same length. And scalene, the one I have underlined in green, that means all sides are different. Awesome. The other way that we can label triangles is based on their angles. So if you look at the columns, if you look at the rows over here on the left, these are all based on angles. So we have acute, obtuse, and right. We'll start with right because I think that's what people probably are most comfortable with. A right angle triangle means that you have somewhere in your triangle a 90-degree angle. 90-degree means that if you were to draw two sides like this, it makes that perfect square shape right here in the corner. It's like a corner, a perfect corner. That's called a 90-degree triangle. Obtuse means you have an angle. Sorry, it's not letting me write. You have an angle bigger than 90 degrees. So somewhere in your triangle, you have an angle that measures greater than 90 degrees. If you're looking to draw something like that, if below we have our 90-degree right here, bigger means it would open wider. So something like this would be a bigger than 90-degree angle because it opened up wider than the 90 degrees below. Wonderful. The third way we have is acute. Acute up here, underlined in green, means that all angles are less than 90. All angles less than 90 degrees. That means that every angle is closed off more than that 90 degree below. So obtuse is opening up wider, acute is closing off. It's making it smaller. We're going to draw some examples because that usually helps. So in each one of these 9 boxes, we're going to draw the situation that would represent the row and the column title. So if in this first box, our job is to make an equilateral triangle that is also acute. So equilateral means all sides are the same. Acute means that all angles are less than 90 degrees. So something like this would be an equilateral acute triangle. I know that because all of these sides are equal. I show they're equal by putting a line through it like that. And if I look at every one of these angles, so there's an angle there, an angle there, and an angle there, all of those angles are smaller than or close off more than a 90 degree. If we look at the second one, in this box over here, we want to create an isosceles, so that means two sides are the same, acute angle. So to do that, I need two sides to be the same. I'm going to do two really long sides like that. Those are the same length. And then we're going to have one side down there, which is definitely a smaller side than the other two. That's isosceles because two sides are the same, but the bottom side is not. It's acute because all the angles are smaller than 90 degrees. Wonderful, scalene. So now we want to create a triangle where all sides are different, and we want it to have all acute angles. So that means less than 90. So if we want to do that, we could draw a nice long side like that. And then we could draw a small side out like that, and then over like that. That looks pretty close to isosceles, to be honest. I could do it a little bit better. I'm just going to sneak that line in a little bit. Ooh, that's tough. Drawing scalene triangles that are acute is definitely challenging. So all these sides are different lengths. All these angles are less than 90. That top one's looking mighty close to 90, but we're going to say it's less than 90. So that is a scalene acute triangle. All right, we're going to go down here and try to create an equilateral obtuse triangle. Now, if you try to do that, it's actually not going to be possible. The reason why is because equilateral triangles have some qualities that are very important. So not only are all sides the same, all sides are the same. In an equilateral triangle, all angles are 60 degrees. So if we had to draw an equilateral triangle, the only equilateral triangle we can build is actually an acute one, because in an equilateral triangle, all angles have to be 60 degrees. Like that. So we actually can't draw an equilateral obtuse, and we can't draw an equilateral right angle. Slide over. We're going to do an isosceles obtuse. So isosceles means two sides are the same. Obtuse means I have an angle greater than 90. So if I try to draw this, I'm going to draw it like this. That is my obtuse angle. That's bigger than 90. And then I'm going to connect the length over here. These two sides I'm going to say are the same. The top side is different. It's not measured perfect. I can't use a ruler on my Chromecast, so this is hard to do. But that we'll just say is the same length. And the reason I'd say the same is by putting that line through. So remember, if we have lines through something like that, it means they're equal. Even on your guys' worksheet in your practice, you're going to notice that sometimes there's lines through, even though it might not look like they're the same. It just kind of helps you realize that they are the same. So that is an isosceles obtuse triangle because the angle is bigger than 90 and two sides are the same. Awesome. Now we're going to try to draw a scalene obtuse triangle. Scalene means all sides are different. Obtuse means I have an angle greater than 90. So if I try this, I'm going to draw one side there. I'm going to make an angle bigger than 90, so it's going to open up like that. And then I'm going to connect the dots. That is an obtuse angle right there. And if you look, all three sides are different lengths. My longest one is probably this one right here. And then this length isn't as long. And then this one's definitely the shortest. So that is a scalene because all sides are different. Obtuse triangle because there's an angle bigger than 90. Perfect. Let's do an isosceles triangle. So an isosceles right angle triangle means I have to have a 90 degree. A 90 degree looks like this. Okay, so there's that perfect square angle. And isosceles means that two sides are the same. I've made those two sides about the same, and then I'm going to connect them. So this and this are the same, making that an isosceles right angle triangle. If I want to make a scalene right angle triangle, I'm going to do two lengths like that. So that's a 90 degree right there. And then I'm going to connect my two lengths like that. That is scalene because all three sides are different and it's 90 degrees, so it's a right angle triangle. Wonderful. That's all of our naming of triangles. We're going to move on to naming. Oh, sorry, it's not loading. Naming more triangles down here just by looking at the picture and just naming it. If you look at this first one, if I wanted to name that triangle, I have two different ways to do it. One is by the sides and one is by the angles. If I look at this triangle, I would say that all three sides are different. Because all three sides are different, this is a scalene triangle. The next thing I'm going to do is I'm going to label this triangle based on the angles. If I look at this triangle, there's a clear 90 degree right there. That means this is a right angle triangle. Number 2. If I look at number 2 and I notice all three sides are the same length, that means this is an equilateral triangle. When I want to name this based on the angles, if I look at the angles, they're all closed off more than 90 degrees. They're all less than 90. So this would be acute. Remember that all equilateral triangles are acute because they have to have angles of 60 degrees. Number 3. If I look at this, I'm going to say that naming this on the sides, this side and this side are the same length. The bottom side is not the same. So I'm going to call this an isosceles. I need to double check I spelled that right. ISOSCELES. Yeah, I did. Then I want to name this based on the angle. The angle on this one, if I look here, that looks to me like it's opening wider than a 90 degree. So if it's bigger than a 90 degree, we would say that that thing is obtuse. Number 4. If I look at that and I want to name it based on its sides, I would say that this side and this side are the same length. We could actually measure them if you had paper and they should be the same. So this would be isosceles. If I want to name it based on its angle, looking at this angle, that is 90 degree right there. That means this is a right angle triangle. If I look at number 5, if I wanted to name number 5, all those side lengths look different to me. None of them look the same. So I'm going to say that is a scalene triangle based on its sides. Based on its angles, I'm going to say that right there is bigger than 90. That means we have an obtuse triangle. This one over here, if we want to look at it, it looks to me like all three sides are different. Since all three sides are different lengths, that thing is a scalene triangle. When it comes to angles, I would say that this angle is less than 90. I would say that this angle is less than 90. And I would also say that this side is less than 90. That means all three are less than 90 degrees or they close off more. So that means this is acute. The way that I remember which one's obtuse and which one's acute. Obtuse is big angle. Big is like obese, like somebody who's big. So that would be an obtuse angle because the angle is big. Cute, when I think of cute, I think of little. Little is something that is cute, like a little cute thing. Right? Like a cute little puppy or a cute little kid or something like that, right? So little angles are cute. Awesome. That does it for triangles. After triangles, what we're going to do is we're going to do polygons. So we're going to do regular polygons. Let's talk about what that means. So regular polygons. Regular means sides are the same. Polygon means there's many sides. Essentially, a polygon just means a shape. So when we're talking about regular polygons, we're talking about any sort of shape with lots of sides. We do from 3 sides all the way up to 12 sides, and then regular means that the sides are the same. So we'll start with a 3-sided shape. The name of a 3-sided shape, we know that, it's a triangle. For a 4-sided shape, we a lot of people like to call them squares. We say that they're quadrilaterals. If you put square, I'd probably take it, but we should try to use the term quadrilaterals. It just describes a lot of 4-sided shapes. So you could have like a square that's not a square, it's a rectangle. You could have a square that's like tilted to the side. You could have a trapezoid. Those are all 4-sided figures, and they technically all count as regular polygons for us. That's just how we describe them. Okay, now the ones that people usually don't know. A 5-sided shape is called a pentagon. A 6-sided shape is called a hexagon. A 7-sided shape is called a heptagon. An 8-sided shape is called an octagon. I like to think octo as like octopus. Octopuses have 8 legs. A 9-sided shape is a nonagon. A 10-sided shape is a decagon. An 11-sided shape is a is a hendecagon. And a 12-sided shape is a dodecagon. You might notice that 10, 11, and 12 all have the word decagon in them. And so for 10, it's just a decagon. For 11, it's a hendecagon. And then for 12, it's a dodecagon. I don't really have any great ways to remember those things. These are things you're just probably going to have to memorize through a lot of practice. All right, we're going to look at pictures now and try to name them. So we've got 8 photos down here. We're going to try to name them. The way you name these shapes or these polygons is by counting how many sides there are. So if you look at the first one, there's 1, 2, 3, 4, 5, 6, 7 sides. 7 sides means we have a heptagon. If we look at our next shape, if we want to name that polygon, we're going to count the sides. There's 1, 2, 3, 4, 5. A 5-sided shape, if we look at our chart, is called a pentagon. If we look at our third shape, if we want to name it, we got to count the sides. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, if we look at our chart, is a hendecagon. We look over to our one on the right. We have 1, 2, 3, 4, 5, 6 sides. Look up my chart. 6 sides is a hexagon. We look over at our one on the bottom left corner. We want to name that polygon. We count the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is a decagon. Actually, I'm going to write the number of sides in the middle so you guys have that. Awesome. If we look at the next one, we count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. That would be a dodecagon if we looked up at our chart. This one here, we count the sides. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 sides. That is an octagon. And our last one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sides is a nonagon. Wonderful. That's naming polygons. So if you look back on the website, you should be able to see a lesson now. So a practice book. If you want to do that, it's just naming polygons, drawing triangles, stuff like that. McKenna, I hope you watched all the way to the end of the video to get your shout out. I hope you're doing well, and I hope all you guys are doing well and having fun in your isolation and quarantine and staying safe and not getting too bored. I know I'm getting a little bored. All right, take care.